Let's take a look at practice quiz 13, focusing on trigonometry. Number 1 wants us to convert the given degree measure to radians, and then in part B, convert the given radian measure to degrees. So to go from degrees to radians, we need to multiply by pi over 180. So what I like to do is write it all together and then just reduce it. So I'm going to put 150 pi over 180. And then the zeros would cancel out, and then they each divide by 3. So 15 divided by 3 is 5, and 18 divided by 3 is 6. So end up with just 5 pi over 6. To go from radians to degrees, you just want to do the opposite, and you want to multiply by 180 over pi. Always put pi in the denominator so it'll cancel out the one that you usually have in your numerator. And then we get 2 times 180 over 3, which would be 360 over 3, which is just equal to 120 degrees. All right. For number 2, it says find a positive and a negative coterminal angle to an angle that measures 57 degrees. So if we think about an angle that measures 57 degrees, we can kind of sketch where it would approximately be. And we want to find a positive coterminal angle. So that means we want to find the angle that would go all the way around and come back to the 57 degrees. So what that means is we would have to say 57 degrees plus 360 degrees would be another angle that would land in the same place. So 57 plus 360 would give us 417 degrees. Now you could keep adding 360 and get other coterminal angles that would also make sense. So you only have to add it once to get one positive coterminal angle, but there are technically infinitely many of them if we were to continue to add 360 degrees. The list would keep going. For negative, you just go in the opposite direction. So the negative coterminal angle would be if we subtract 360. So 57 minus 360 degrees would be a negative 303 degrees. And again, you could continue to subtract 360 multiple times and get different coterminal angles. So there are many, infinitely many, that we could find. That's just the quickest one, is to subtract 360 one time. But you could continue to subtract. Number 3 says find the exact value of the following. So that means you want to think about your unit circle and what would be the exact value. So no decimals for this one. So 225 degrees is located over here in between 180 and 270. Right in the middle, we have 225. So that is the square root of 2 over 2, and it would be negative. And then the same thing for the y value, and they're both negative because this is our third quadrant. So remember, everything is negative in the third quadrant. And then we want the sine of 225. So remember, sine is the y value for that coordinate. And so that would just be negative square root of 2 over 2. And so that is the answer to this question for part A. Part B says cosine of 30. So you want to think of 30 degrees is right here. And the coordinates of that point are the square root of 3 over 2 and 1/2. And the cosine is always the x value. Think about alphabetical order. X goes with cosine and y goes with sine. They're alphabetically in the same order. So I would just want to pick out the square root of 3 over 2 for the cosine of 30. And notice those are not something that I would want to round off when I'm asked to find the exact value. They just want you to leave it in that radical form. Moving on to number 4, it says graph one cycle of the following function. Y equals 3 sine of x plus 1. Make sure to plot the 5 key points. So let me bring up Desmos. You can do it by hand, but you can also use Desmos. So let me bring that up to show you both. So I know things about this graph, like sine always starts at 0, but this one has shifted up 1 and has an amplitude of 3. Those are the things I can see by looking at it. So I'm going to type in 3 sine of x plus 1. And then what I can do is change it to radians, because that's usually how we see it plotted. And then radians. And what you can do is make it so you have a step of pi over 2. So it just basically matches the graph I was given right there. So my step is how much I want it to be in increments of, so I can just easily plot it on my paper. So I see I have a y-intercept at 1. At pi over 2, it's located at 4. So 1, 2, 3, 4, which makes sense because we have an amplitude of 3. So notice, like, between the starting point and the highest point, there were 3 units, which goes with our amplitude. So back to pi, let's see. That one would be, let's see if we can get it to land right on there. Let's see, pi is 3.14, but it should be at pretty much 1 is what I'm going for there. So 1, and then the next point would be down 3 more units. So notice, like, the amplitude from my highest point and to the middle, and from my middle to the lowest point, those are both equal to 3, which helps me pick out the midline, like if I was asked for that. But in this case, we're just graphing. So this helps me to sketch my graph, and I can see that I have a midline that actually would be at y equals 1. So if I was asked about that, that would be the midline. And I have an amplitude of 3 because it goes from the middle to the lowest and from the middle to the highest point on the graph. But all we need to do for this question is graphing. So I'm getting a little carried away. So I'm going to move on to number 5. Given y equals -3 cosine of 2x plus 4, state the key features of the graph. So let's just type it in Desmos. That way it's there if we need it. So -3 cosine of 2x plus 4. So I can see amplitude is pretty easy to pick out. That's just that number in the front, and it's always positive. I'm going to write that down. It is always positive. So even if you have a negative, that's a transformation, but the 3 is our amplitude. The midline is the middle of your graph. So it's like the amplitude goes up and down, but the midline's right smack dab in the middle of your highest and your lowest point. So you see how on my Desmos, I see I have a 1 is the lowest and 7 is the highest. So your midline's right smack dab in between 1 and 7. So between 7 and 1, there's 6 units in between there. So you want to go up 3 or down 3 to get to the middle. So 7 minus 3 or 1 plus 3, either way we get y equals 4 for our midline. I'm going to write that in a different color. So it should be equidistant from your highest and your lowest. So that would just be y equals 4. And when you type it into Desmos, it should look like it makes sense. So I'm going to just type it over there. And I can see that that looks like it is indeed in the middle of my curve. The period of the graph is how far it takes for one full cycle to occur. So I can see that the period on this graph looks like it just occurred by the time I got to pi. The other way you can pick it out is you can see that you have a 2 in front of the x. So you always want to say 2 pi divided by whatever's there, and then that would just leave me with pi for that reason. But for either way you look at it, just looking at the graph or using 2 pi divided by your frequency, you get pi. The transformations of this graph are that we had a negative in the front, so it reflected over the x-axis. They had an amplitude of 3, so that made it have a vertical stretch by a factor of 3. It had the 4 in the back, so that made it shift up 4. I'm going to write that down. Shifts up 4. And then the 2 makes it have a horizontal compression by a factor of 2, because notice your period is half of what it typically is. So it's typically 2 pi, but now it's shorter, so it compressed. So it was a horizontal compression by a factor of 2. Okay, so I think we've got everything we need for number 5, and that is it for practice quiz number